All right, what's up, algebra? Today we are starting a new section. This is 7.6, which is exponential functions. All right. So we'll go ahead and jump into it. Our goal here is to be able to evaluate and graph exponential functions. That's just functions with exponents. All right, so we'll go ahead and jump into it. All right, so an exponential function, we've got it right here. Basically, it's a function that has the form y equals a times b to the x. Okay. The main thing that you're going to notice that's different between an exponential function and just a linear function is that our graphs kind of curve. So you can see that like here, this one curves. Okay, this one down here curves. Okay, that's really the main thing when you look at them visually that's different between these and just linear functions like we've been looking at so far. All right, so when we actually look at what makes them different, why exponential functions curve, I think this little paragraph, this in your book is on page 454, by the way, but I think this kind of sums it up pretty well. Okay, so if I start right here, it says if all the y values have a common difference, then the table represents a linear function, right? That's what we've looked at in the past. Okay, and then if all the y values have a common ratio, then the table represents an exponential function. Okay, so problem 1 really shows that pretty well, especially with example A. That's an exponential function, but before we get to that, let's just look at a linear function. Okay, so for a linear function, first of all, on both of them, the x is going to increase by a constant rate, right? The y is where it's going to be a little bit different. We're going to have like a constant ratio, right? So for this one, if we look at these, okay, the rate for the x's is +1, okay, whereas the rate for the y's, that's always +2 the whole way through, okay? This shows an example of a linear function, okay? The reason I showed you that is now we're going to look at problem 1a, where they show us one that is not a linear function. Okay, so if I go ahead and erase all this for us, they give us one that is an exponential function. Okay, so the x's are still going up by 1. All right, but now instead of going up by a constant rate, the y's go up by a constant ratio. So they have this written out. Okay, what I mean by a constant ratio is each time the number is multiplied by 3, right? So times 3 times 3 times 3, okay? You'll notice that these are different, okay? A constant ratio is where it's multiplied by 3, okay? But there isn't a constant a constant difference between the values, okay? You can see that here. -1 and -3, the difference is -2. But then this one, the difference would be -6. Okay, so that is not linear, but based on this stuff, we can see that it is exponential. All right, so that's if we're looking at a table. Now if we look at problem B, okay, this one, we've got y equals 3x, okay? Whenever we're looking at a rule or an equation, it's really easy to tell whether or not it's exponential or not. If it doesn't have an exponent, then it is not exponential. Okay. So that's really, that's one great way to be able to tell. Okay. It is important for an exponential that we have the we have the variable as an exponent. Okay, so that would be like this. Okay, the exponent has to be our variable. Okay, if it's not a variable, that's a different type of equation or function, which we will get to later on in the school year. But for now, just know it's exponential if we have a variable there. Okay, so this thing that I just circled for a second time now, that would be good to write down and make sure you know. All right, so on your own, I want you to go ahead and try out Got It Problem 1A and Got It Problem 1B. Shouldn't take you too long, but go ahead and do those real quick, and then afterwards we will move on again. All right, Got It Problem, or sorry, not Got It Problem, just Problem 2. It's pretty straightforward, okay? This is just evaluating an exponential function, okay? So for that, all we're doing is really just plugging in, okay? So it says population growth, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function of f of x equals 30 times 2 to the x gives the population after x weeks. How many beetles will there be after 56 days? Okay, well, first thing you've got to do is find out how many weeks 56 days is. Okay, there's 7 days in a week, so I'm going to divide 56 by 7. That should give you 8 weeks. Okay, so with the function f of x equals 30 times 2 to the x, I'm just going to plug in for x, 8. So now we have f of 8 equals 30 times 2 to the power of 8. Okay, I know that 2 to the power of 8, I believe that's 64. Nope, that's not 64. I don't know what that is. It's 256. 64, what am I thinking, right? Okay, so we have 30 times 256, and then I've got to check the answer on that one too, 7680. All right, so there would be, after 8 weeks, 7,680 beetles. Okay, so I think this is actually a great example of just being able to see how quickly things go up or increase when they are an exponential function. All right, we started with 30 beetles. Imagine that in the real world, right? You start with 30 beetles, and suddenly after not even 2 months, we've got over 7,500 beetles, right? That's pretty crazy. But yeah, so that's how those work. All you got to do is plug in for the variable. I won't have you do Got It Problem 2 because I think you guys are capable of plugging in for the variable, and that won't really be an issue moving forward. All right, so graphing an exponential function really just works the same way as graphing any other any other function that we've done, right? So I'm not going to go into too much detail on this, right? But if we have the graph of y equals, let's, I don't know, go with just 2 to the x, right? That's an exponential function. Pretty simple one, okay? If I was to graph this for an exponential function, okay, you just want to plug in your x's and y's. I'm going to do 0, 1, 2, 3, okay? So then I would plug in 0 for 2 to the x, which would be 2 to the 0, which is 1. Okay, do the same thing here. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. Okay, then I would go over here. I can graph that, right? I'm going to have 0, 1. And then I'll have 1, 2. 2, 4. Okay. It should eventually get to something like this when we graph it. I know I didn't go into a whole lot of detail on this graph, but really it's just plotting points, right? There's nothing new here, okay? Because of that, again, I'm not really going to have you worry about doing Got It Problem 3. I just want to make sure you have that chance to see what it should look like. It should be a curved graph. Other than that, all you're doing is plotting the points. Nothing new. All right, so problem 5 here, we actually don't do this. We will do this, or sorry, I guess we won't, but you will do this when you get to Algebra 2 in high school. So I'm just going to cross this out for now, and you don't have to worry about that. So yeah, that is it for this video. Not too bad, just about 10 minutes long. So I will go ahead and be done there, and I will see you guys in class.